For the third time in program history, Boeing is preparing to launch its Starliner spacecraft. The mission is the crew flight test, and it will be the first time this capsule carries astronauts to the International Space Station. The crew on board are two NASA astronauts, retired Navy Captain and CFT Mission Commander Butch Wilmore.
It's an amazing place to be because you know the heritage of what it means. This is only a handful of spacefaring nations on the globe, and you're in a nation that is one of them, and your nation has decided that you're okay enough to be in the rocket, to be on the pointy end and go, and it's humbling.
Retired Navy Captain and CFT Mission Pilot Suni Williams.
We've known each other for a long time, so respect was always there, but I think you build the trust with each other when you get stuck in a spacecraft together or go do a spacewalk. You know, those types of things are very memorable and important aspects of your life, right?
Both are also seasoned test pilots and will put the Starliner spacecraft through its paces to verify that it's ready to support long-duration missions in low Earth orbit.
It's really fun to be in these testing and development programs because when you're doing something for the first time, it is just a different mentality. And when you talk to them, you know, they really feel ready. The team really feels ready. We've had lots of challenges like you would expect when you set big goals, you're going to have challenges, but it's nice to see that everybody feels good. Excellence is required as always, but this team looks like it's ready to go. That's pretty exciting.
As the title of this video suggests, you're watching part 2 in a 2-part series talking all about the Starliner program. And if you haven't seen part 1, you can go ahead and pause this video, save it for later, click this card in the upper right-hand corner of the screen, and it'll take you to part 1, in which we talk about the Starliner spacecraft and how it came to be and its history through the commercial crew program, from the pad abort test leading up to OFT number 1, and finally OFT number 2, which of course sets us up for this mission, CFT, the crew flight test. If you're all caught up, or you just want to go ahead and learn more about the crew themselves, the training they went through, and the mission profile from launch to landing, you've come to the right video. And let's go ahead and start with the crew themselves, the history of how we got to this duo right here, Butch Wilmore and Suni Williams. Throughout the development of the Starliner spacecraft, one of the most consistent presences was the man set to command the crew flight test mission, Chris Ferguson. The veteran of 3 space flights and commander of STS-135, the final space shuttle mission in 2011, was hired by Boeing as its own astronaut. He was among the Boeing employees who unveiled the name of Starliner back in 2015. A milestone of NASA's commercial crew program came in August 2018, when then NASA Administrator Jim Bridenstine introduced the world to the primary crews of the first CCP missions. On the SpaceX side, Doug Hurley and Bob Behnken were named to the first astronaut mission for the SpaceX Dragon spacecraft. For Boeing, NASA tapped Eric Boe, Chris Ferguson, and Nicole Mann. At the same event, NASA also announced the astronauts for the first 6-month crew rotation missions for each spacecraft. Dragon was receiving Victor Glover and Mike Hopkins. Starliner was receiving Josh Cassada and Suni Williams. Those combinations got shuffled over time, though. In January 2019, Eric Boe was removed from the Starliner CFT mission due to medical reasons and was replaced by veteran NASA astronaut Mike Fink. As Starliner continued to face development delays, in October 2020, Boeing astronaut Chris Ferguson stepped aside for family reasons.
I'm deeply committed to human spaceflight. I'm dedicated to the Starliner program, and I'm passionate about the team that has built her. But next year is very important for my family. I have made several commitments which I simply cannot risk missing. I'm not going anywhere. I'm just not going into space next year. The Boeing team has been very understanding. The crew is doing wonderfully, and thank you for your understanding too.
His shoes were filled by Butch Wilmore, making the team Wilmore, Fink, and Mann. In August 2020, NASA astronaut Jeanette Epps was assigned to the Starliner-1 mission.
I'm super excited to join Suni Williams and Josh Cassada on the first operational Boeing crew mission to the International Space Station. I've flown in helicopters with Suni flying, and I've flown in the backseat of a T-38 with Josh flying. And they are both wonderful people to work with. So I'm looking forward to the mission.
After Boeing had to stand down, though, from the second orbital test flight attempt in July 2021, that October, NASA moved both Nicole Mann and Josh Cassada off their Starliner missions and put the duo onto the SpaceX Crew 5 flight. NASA said that it wanted its rookies to get some flying experience. Japanese astronaut Koichi Wakata, who had also previously been assigned to Starliner-1, was added to Crew 5 as well. During a NASA briefing in the run-up to the second orbital flight test of Starliner, Wilmore, Fink, and Williams joined NASA leadership on the dais and were called a cadre of Starliner astronauts. Kathy Leaders, NASA's Associate Administrator for Space Operations at the time said a final decision on the crew assignments was still in work.
We are getting our crewed flight test vehicle ready to go by the end of the year. The Boeing folks are working hard to get it there and ready to go. But one of the things we have to do is do this mission and take the learning that we will get. We know we'll have learning out of this mission, and then lay that into our plans and our schedule with the Boeing folks after we return. So I think when that happens, we'll also look at what's the crew complement for our crewed missions that we have next year and the other activities we have going on, and we'll make a final selection for the crewed flight test vehicle at that time.
A month after OFT-2, Suni Williams was moved from the Starliner-1 mission to CFT, and Mike Fink was named as the backup pilot for the CFT mission. In September 2020, NASA astronaut Scott Tingle was named as the Starliner-1 mission commander, and Jeanette Epps began cross-training on SpaceX's Dragon, foreshadowing her ultimate reassignment to the SpaceX Crew 8 mission in August 2023. Most recently, Canadian Space Agency astronaut Josh Kutrick was named as a mission specialist for the Starliner-1 mission and will serve as Capcom for the CFT flight. With that latest addition, here's the current makeup of the two first crewed flights of the Starliner spacecraft: Butch and Suni on CFT, and Scott, Mike, and Josh on Starliner-1. LeRoy Cain, the Deputy Starliner Program Manager, spent decades at the Johnson Space Center working in flight control going back to 1988, and said he got to be part of all of Butch and Suni's missions over the years.
All in total, I supported more than 100 space shuttle missions in my career with NASA. As a flight controller, as a NASA flight director, then as the Deputy Program Manager for the Space Shuttle program, and the chairman of the Shuttle Mission Management Team. In those capacities, I supported over 100 space shuttle missions. So I worked every mission that Butch and Suni ever flew. And so I've known them for all those years. Now, I didn't at that time, of course, to answer your question, I didn't envision that the three of us would be working together in this kind of capacity at some point in the future, but I'm certainly glad that this is where we are.
They've had a large team around them to develop the Starliner program. Spaceflight now got the opportunity to visit the Johnson Space Center in Houston and check out some of the tools used to train both Butch and Suni. So this is a mock-up of the Starliner spacecraft. It's what Butch and Suni have been using in their final days to go over some refresher courses and make sure they know all the correct loading procedures as they get into the capsule here. Right now it's in a configuration where both the two astronauts that are going to be flying to the station during CFT will sit in these two seats behind me. But where I'm kneeling right now, and this space behind me where this cargo bag is stored, are actually places where two additional seats can be placed if and when Boeing needs to fly 4 astronauts, which will be coming up, of course, in the later missions. In addition to the seats and the cargo, this capsule features a medium fidelity control panel for the crew, as well as the main hatch, which will be used to enter and exit the spacecraft on the ISS. NASA's Nicole Jordan explained some of the thinking behind the seat design, which you may notice isn't super roomy. But she says that's actually very much by design. It's one of the lessons that NASA learned from NASCAR.
And one of the lessons from NASCAR is that human bodies can take huge loads as long as there's no relative motion between the person and, in this case, the race car. And so NASCAR, one of the things that they have done is they've added a restraint between the helmet and the shoulders so that your head is physically restrained from, moving too much from your body, right? It's called a Hans device. And so here, you really want it to be pretty snug, because if you have room and then you hit hard, you don't want to accelerate and hit the seat. That could cause an injury. And so we want it to be pretty snug. And so, as was pointed out earlier, that's one reason why you don't see a lot of padding in the seat. There's kind of minimal padding for hot spots and comfort, but you don't want to have too much padding because of that. You want to have very little relative motion if you have like a high impact event.
Another key piece of the development pie are the spacesuits that Butch and Suni will be wearing during launch and docking operations. Boeing calls them Ascent entry suits, or AES, and they come in a range of sizes, from extra small to extra large, to fit a wide range of astronauts. Part of the training, of course, is going through the suit-up process. Part of that involves the gloves themselves. These are specially sized, and there are 10 different varieties of these gloves that are available, ranging from 1 to 10. And some of the sizing differences are dependent on your finger length, finger width, and of course, dealing with the palm itself. It has this separate latching mechanism once you're in the suit, so once you've pinched it together, and you can see it a little bit easier when you've got an arm attached to it. That'll let you know that you've got a good tight seal on the glove. But these are designed to be especially dexterous, and they've got special interface so that the astronauts, when they're suited up in their spacesuits in flight, they're able to interact with Samsung tablets throughout the flight process. Tori Wills-Pedrati, the Starliner spacesuit lead, walked us through some of the major features of the spacesuits, using an extra small suit as an example. On average, the basic suit weighs between 15 and 20 pounds.
This layer that you see here is called a bladder. So this is actually what inflates interior to the suit and what will seal for the astronaut in case we need to pressurize. Each AES is paired with boots. These come in 10 different sizes and were developed with the San Antonio Shoe Company. This suit uses a plastic tooth zipper that allows for pressurization because of how the teeth fit together. So the teeth will lock like a zipper would normally on your jacket, but there are double rows of teeth that allow it to lock and interlock to allow for pressurization. This is a waist entry suit, so the astronaut will actually put the suit on like a pair of pants and then pull into the top, swim into it like you would go into a sweater. There are 2 zippers on this suit. One here at the waist, which is our waist entry zipper, and then one at the helmet, which we call are either the helmet zipper or the visor zipper. So this piece here, polycarbonate, is the visor. It allows the crew member to have a wide range of view while in the vehicle. Typically, the visor zipper is open and the crew is able to have their visors off. They only don their visor and zip it up during dynamic phases of flight, such as launch, through most of Ascent, launch and Ascent, docking with station, undock with station, and then re-entry to landing.
Turning from the suits to the spacecraft training, Boeing and NASA have a number of tools they use in coordination with the astronauts. One of them is a high-fidelity mock-up of the console on Starliner called the Boeing Mission Simulator.
You see a lot of switches that are reminiscent of aircraft-style switches like we had in the shuttle. Some of those are 2 or 3 position switches, which are simple toggle switches. Some of those are called lever lock switches, where you actually have to pull the switch out and move it up or move it down. And that's, I tell people, you've got to mean it. Those are important switches.
The mock-up is designed to put Butch and Suni through a variety of training exercises and contingency scenarios.
And I've been around for a long time. I was a long-time shuttle instructor and trained many shuttle crews. But I came into what was for me a new program. I'm learning a new launch vehicle, and now I have a new crew to get used to, and I have to learn the things they like and the ways they learn. Everybody learns differently, right? And how to interact with them, how to get the most out of them, how to prod them when they need prodding. It's been great. They asked for me to come aboard this program, and that was a big honor for me.
Because the BMS is somewhat of a cramped learning environment, though, Butch and Suni also spent quite a bit of time in a classroom environment called a crew part task trainer. Ray Bigones, the Starliner lead rendezvous officer, walked through a docking simulation for us.
Vesta cameras are showing the crew where the space station is in the imagery, but also where the spacecraft thinks the space station is in the green outlines. So the crew can see exactly where the computers are flying. The crew also has this display, which is a center-on camera. There's a camera very much like the one you have in your hand right now that is mounted in the hatch on the center line of the spacecraft, right in the middle of the docking port, and that goes to this tablet. And you may notice it's not built into the crew displays. It's not built into this main console here, and that's on purpose. It doesn't need any of the Starliner computers to be running. It doesn't need anything from Starliner. It's a completely independent and dissimilar system, and that's the way we designed it on purpose.
Finally, when crews are either at the Johnson Space Center or in other locations around the world, they can use a virtual reality setup from Vario to be able to go inside the spacecraft from anywhere. Connie Miller, an associate tech fellow with Boeing, showed me around the virtual cockpit and how to interact with the system.
This is just a prototype here, but you should be able to interact with the buttons, flip switches, do things like that, and kind of get a feel for the capsule size.
Oh, that's trippy. The mission itself is being overseen through various flight control directors. They are NASA employees who Boeing contracted for various stages in flight. Kelly Beck is the Mission Operations Manager, and Jennifer Hammond is the Mission Operations Manager for the space station. As we break down the mission profile, we'll introduce you to some more of the flight directors overseeing the various stages of the CFT mission. Launch begins with the liftoff of the Atlas V rocket at Space Launch Complex 41. 12 seconds into flight, the vehicle will roll to line up Starliner with its target orbit and move Butch and Suni into a heads-up position. The Atlas V will reach max Q, the point of greatest aerodynamic pressure on the rocket, about 45 seconds into the ascent. The RD-180 engine on the Atlas booster will throttle up at T plus 1 minute and 7 seconds. That's followed by the conclusion of the solid rocket booster burn at T plus 1 minute and 33 seconds. The SRBs separate from the booster about a minute later. The Atlas booster will continue for another 2 minutes before booster engine cutoff or BECO, and then the booster separation happens about 6 seconds after that. The Ascent cover at the top of the Starliner is jettisoned at about the same time as well. 2 RL-10A4-2 engines on the Centaur upper stage ignite at T plus 4 minutes and 48 seconds, and the aeroskirt is jettisoned just after the 5-minute mark. The Centaur upper stage will continue its burn until nearly 12 minutes after liftoff. The Starliner spacecraft separates from Centaur about 15 minutes into flight. Finally, Starliner will conduct the orbital insertion burn at about 31 minutes after liftoff. Mike Lammers is the flight director for Ascent and Entry.
What's really kind of cool about Starliner is that it's very much a kind of a pilot's spacecraft, right? So it's really maneuverable. I mean, I'm sure folks have given you some of the technical details, but there's close to 50 reaction control and orbital maneuvering jets on it. And and there's a stick. And what's really cool about it is when you have astronauts that are pilots, they really gravitate towards using it.
A little less than 23 hours after liftoff, Starliner will fire its orbital maneuvering and attitude control, or OMAC thrusters, for a burn called NHPC-1. That will begin raising Starliner's altitude. The second burn, NHPC-2, happens less than a minute later, which moves Starliner to within kilometers of the ISS, but behind it. The next burn, NSRPC, puts Starliner on a co-elliptical path with the space station's orbit. At this point, crew will don their spacesuits ahead of the TPI, or terminal phase insertion, burn nearly 25 hours into the mission. There will be a pair of inbound fly-around maneuvers to put Starliner at the correct speed and in front of the station. Starliner makes its initial approach at about 25 hours and 20 minutes after liftoff. At this point, Butch and Suni will manually command Starliner to hold its position to verify that it can do so. It will be about 260 meters away from the station at this point. Starliner will enter the so-called keep-out sphere at about 25.5 hours into flight, where it will perform stop and retreat maneuvers. Following that, it will continue its approach until it reaches 10 meters at 26 hours and 2 minutes into flight, where another pull will be taken before final approach and then docking. This part of the mission is overseen by Ed Van Cise. He says he's looking forward to watching some of the manual operations of Starliner during this stage of the mission.
It's a test flight, so we're getting into tests and checkouts, and we're going to put the vehicle through its paces. We know the automated system works. We did that on OFT2. Now we want to really shake it out and see all the other capabilities that it had.
Finally, after spending about a week at the space station, Starliner will undock from the ISS. When separation occurs, Starliner will begin its retreat until it exits the keep-out sphere about 22 minutes after separation. 26 minutes after separation, Starliner will perform an outbound fly-around maneuver to collect high-quality images of the space station. 41 minutes after undock, Starliner performs the departure initiation burn. As Starliner continues the journey back to the ground, it points its solar panels at the base of the service module towards the sun to charge its batteries. About 44 minutes before landing, Starliner begins firing its thruster for the deorbit burn, which lasts about a minute. It slows the spacecraft down below orbital velocity. After re-angling itself for re-entry, about 40 minutes before landing, the service module will separate. The big milestone is the entry interface about 22 minutes before landing. Starliner encounters temperatures of about 3,000 degrees Fahrenheit while it's descending from 400,000 feet above the Earth's surface. Starliner will descend to 100,000 feet about 6.5 minutes before touchdown. Less than 2 minutes later, the forward heat shield jettisons, beginning the parachute sequence. The drogue chutes deploy seconds later to slow the vehicle, and at 3 minutes and 30 seconds before landing, the 3 main parachutes are deployed. Once that happens, the bucket handle at the top of the crew module releases, which will level out the spacecraft. The base heat shield is separated at about 3,000 feet up, allowing the airbags to inflate with nitrogen roughly 30 seconds later. And last but certainly not least, crew lands in the southwestern United States. The whole CFT mission is designed to prove the capability of Starliner to begin flying regular crew rotation missions to the ISS and back, something that Butch and Suni are excited to prove out.
You think launch, all the uphill, rendezvous docking, all of that is fascinating. But to be able to put your hands on the controls and assess the various capabilities for the first time, I mean, wow. I mean, that's pretty special. And I'm grateful for the opportunity, and I think it's a necessary thing we do, because we are the ops control for specific capabilities. Failure modes within the spacecraft comes down to the crew's hands. And so we need to prove that those things are as designed, and we can only do that by testing them.
And that test is CFT. Reporting for Spaceflight Now, I'm Will Robinson Smith.